All right, thanks everybody. I hope the workshop's going well for you. We find it useful at workshops to take a moment and just talk about the different programs we have at the facility so that you have a sense of sort of maybe what you might want to target and where your project might fit in. And I encourage, I love questions, and so I don't, obviously presenting, right? I don't have the questions in front of me at the exact moment, and you can't raise your hand and interrupt me as easily. But I encourage them. There's a lot of different programs. I'll talk about a bunch of different things, but hopefully people will have some questions about where they might fit or understanding the program some more. And some of this I will go through the very first beginning of this talk quickly, because some of this you've already heard before, right? I'm not going to go into depth on the Theta hardware and the Theta GPU hardware. I will point out though, because it's relevant to the programs, right? We are a national user facility, right? So our mission is focused on delivering compute capabilities for open science, right? So anyone can apply to use our systems. There's no funding restrictions or anything, right? That's part of the definition of a user facility, but also that the work done on these machines is published, right? So that this needs to be published in some timely fashion in any of the sort of the standard mechanisms we have to publish scientific research. Our goal is at the leadership computing facilities is to have supercomputers that are about 10 to 100 times more powerful than systems that you might typically get access to. As you might be aware, right, we have Theta on the floor right now, which is actually kind of modest for what scale we would expect out of a leadership computing facility. And that's in part because we kind of skipped a system on our way to Aurora, which I'll talk about in a minute, but we skipped what would be like a few hundred petaflop system. So one of the changes that happens as a result of that is actually the total number of allocations on the project, on the system, our primary big allocation programs, that drops down in order to give people instead allocations that are really substantially larger than they would be able to get on typical systems today. And I'll talk about that also a little bit more to touch back and give it some context in just a second. As I said, I'm not going to talk too much about the hardware of Theta, but Theta is our primary resource. So when I'm talking about allocation programs right now, everything is targeted towards Theta, and even other systems that will be coming on the floor over the course of the next couple years, the programs are still really primarily focused on Theta. And as you probably know, right, when we deployed Theta several years ago, it was really focused on bringing simulation data and learning right into one system and trying to enable that as best as possible at that time. And that's not just even through the hardware of Theta, but it's through the design of our facility, right? So we really try to design the facility and improve the design of the entire facility as we go forward to better enable the science that is being executed. And so this includes things, right, like substantial improvements and upgrades to our file systems that are happening this year, but also tightly coupling other resources, right? So our visualization and our data resources that we're coupling tightly with our large compute resources. This is just my standard quick comparison chart, right? If you had somehow lost track in the past couple of days about hardware specs on Theta, and again, I'm not going into it, but why I have this slide still here is to point out that over the course of the next year, we will have an intermediate machine that we're going to be putting on the floor, Polaris. It's going to be about 5 times what Theta is today, at least 5 times what Theta is today. And is actually one of its primary missions is a bit of a stepping stone for Aurora, not even on just on the scientific side, but also even on the software stack that'll be going onto the exascale systems that the DOE will be deploying in the next 2 years. And so we have Polaris, and then of course in 22 we will have Aurora, which is our exascale system coming online. And the short version of this is it's a big exascale system. It will be coming in 2022. It is a discrete GPU system. And relevant to this talk, I'll say that the allocation programs are beginning to think about this, right? And I'll talk about this with Insight in particular, that projects are beginning to think about, on the out years of their projects, how they might be using Aurora, but it is not necessarily hardwired into that allocation process yet. And for your reference more than anything, because I don't want to harp on the hardware as much as talk about the allocation programs, This is the high-level configuration for Aurora with just some general guidelines to give you a sense of the scale of the system. And then these are the software tools that we expect to be available. I think the short version of this slide is as you're probably scanning for the particular software tools you use, that this is a starting list, but this is also expected to be probably one of the more robust software stacks. Really, I think you can expect that the software stacks will be a little bit more complete, we hope, right, in the time frame for Aurora, and broad, right, in terms of the sources of the software. All right, so given all of that, we have Theta on the floor today. We expect Polaris in the course of the next year, and Aurora coming hot on Polaris's tail. What can you do to get access to these resources? What does it mean? What machines are in what program? And what does that mean? And that's what I'm going to walk you through today. We have three primary ways you get access, but the idea is that there are different pipelines to get into the ALCF to start using their resources. And I'm going to kind of walk them through, walk you through all of them, but I'll start with the breakdown of sort of where the time goes, right? There's only 100% of a particular machine. Break down that 100% and then walk through what those programs look like. So if you have not seen this before, our primary allocation program is Insight. And Insight takes 60% of the machine. It's really the flagship program. It is the program that sort of captures the complete open science nature of the facility. So anyone can apply and potentially win time, but it's a very competitive process, and it is 60% of the resource. 20% goes to the Oscar Leadership Computing Challenge, and that's the ALCC program. And the reason that's not purely an open science program is that's really a program focused for the Office of Science. The Office of Science executes that program and looks for projects that are aligned with DOE interests. And I'll talk more about what interests means in a little bit. But it's a little bit more aligned with DOE mission. And so given that, it can be a little bit more restrictive in terms of applying. No one is prohibited from applying, but can be a little bit more restricted in who they might be seriously considering. But the first bulk I'm going to talk about is our discretionary program. And this is 20% of our resource, but I'm going to talk about it because it has a lot of different goals, right? It has a broad mission compared to, say, Insight and ALCC, which is really focused on delivering groundbreaking science and engineering. The director's discretionary program might be delivering some of that in some of its roles, but is also really serving the role of a ramp-up program, right? Getting projects ready to compete, say, for an Insight and ALCC, but it also serves strategic roles and even both facility, lab, but also DOE strategic goals. So for example, 10% of that director's discretionary time goes to the exascale computing program right now. And that's this larger program that the DOE is running in order to prepare applications and software for exascale. Okay, this slide I'm not going to walk through, but I'll say it's again at the bottom of my talk, at the sort of the end of the talk, sorry. And I find this a useful quick reference, right? If there's one slide you might want to have around if you're thinking about programs and where you might fit or what timelines you want to think about for different programs, I find this slide is very useful for people. It gives you a sense of the mission of each program, but also like the time frame and the scale of the awards. So a couple of things I'll point out from here, even though they'll come up later. It gives you the sense, right? The Insight program is really focused on these 1 to 3 year long-term projects, right? So we really do have quite a few projects that apply as 3-year projects because they have a pretty large problem or set of problems that they're trying to solve, right? And it really is this cohesive thing that requires that long investment in time. For ALCC, it is a focused 1-year proposal. They're normally not looking at prolonged projects, and they've been pretty consistent about that over the course of the years of this program. For the director's discretionary, right, they're much shorter lived, right? These, if you think about one of the common uses of the discretionary, which I'll get to, which are preparing for proposals, these tend to be 3 months, 6 months, and sometimes 1-year proposals. And there are a lot more of them. So if you think about like 10% of the entire machine, right, is going into this pool that isn't used by exascale computing program, you've got maybe on the order of 100, if not more, projects in that pool compared to Insight, right, where you're looking at 10 to 15 projects. And while there's no hardwired number that an Insight project gets this many million node hours and a DD gets this, this few node hours, it helps you sort of get a sense of the scale there about what we expect, but not only what we expect, what we're able to support effectively. One of the other things I'll point out is really the programs also have a broad range of readiness requirements. And what readiness means here is how ready are you to exploit a large scale system, right? Is your software ready? Is your workflow ready? Are your tools ready? Do you have even the people on hand, right, to execute the science work that you're trying to do? And the readiness requirements on Insight are very high. And I'll touch on a little bit about what that means. And there's more information available that after this talk that you can look at. ALCC is a lot more mid-range, right? For a big proposal for ALCC, they're going to expect a little bit more readiness than for a more modest proposal in ALCC. And ALCC programs, projects can vary pretty substantially in size. But for discretionary, right, this is a program whose specific goal is to take projects that might not be ready, right, for these big programs and help them get ready in both collaboration with us and just through access to the resource and trying to use it. And so there's not that same level of readiness review on a discretionary project. I will point out, and I'll repeat this again, that the call for the ALCC projects, which for 2021 and 2022, so they're on a yearly allocations, but they start mid-year. So that call is open right now, and they have required letters of intent / pre-proposals, depending on how you want to think about it, due on January 4th. So if you're considering an ALCC, move fast. Those are required pre-proposals, and we can give you the links to look at that if you're interested. All right, so diving in a little bit more into the discretionary pool, right? I want to give you a sense of some of these different pipelines we were talking about. As I said, right, these are primarily meant to be small, getting started awards, and they are one common question we get, right, with discretionary is if these are getting started awards, preparing for proposal award, what is the mission? Can I get an award just to do, some science work? And one thing I'll say is that we try to dissuade people necessarily from just applying because I want to get the science question answered. It's often in the process of sort of working on a proposal, we do understand, right, that it's rare that you can just run, try to scale your particular workflow up 10 or 100 times and have no need to validate that or sort of make sure you're making reasonable scientific steps, taking reasonable scientific steps. So we expect within these that really the goal is writing a larger proposal, but that in the stages to that science probably is going to happen, right? And that is fine, but not necessarily to ask for a small award just because you need some compute time to get to get a science question answered. So as I said, these are really considered these first step projects, and anybody is available. Again, this is consistent with the message, that I want people to take away, that anybody in academia and industry, research institutions is open. There's only really a few very small number of countries that we can't give access to. But other than that, anybody can apply. But what we do require, right, is that you have some demonstrated need to come and use the resource, right? That you are thinking about this larger scale problem that needs to use something like an LCF. As I said, the time scale of these tends to be short, but it's not hardwired, right? So you might get a discretionary award that's for 3 or 6 months, but they're very often renewed, right? So the premise is not that you have 3 months, if you get a 3 months DD and then you're out. The premise is that you have 3 months and then after that time, right, or 6 months after that time to come back and sort of just report on progress, right? When we have these big awards like through Insight and ALCC, we have mechanisms to sort of interact with those PIs in order to get their how they're progressing and understand what work they're getting done. We have to talk about what work gets done on our machine, right? We have to talk about the science progress or the way that we're contributing to the community. And so one of the other premises behind, like, just come back in 6 months and ask for renewal, but we also need to just understand your progress. And if something interesting has happened, it provides that touch point, equivalent to sort of just a quarterly report effectively. And while it does say here that the total percent of resources is 20%, for these getting started projects, I'll remind that it shares this 10%, right? Because out of that 20% right now, half of that 20% is going to the exascale computing program. One of the other missions we use to run the data science program, one of the other missions we use for the DD for is to sort of elevate communities that might need an extra bit of help, or might even just need a little bit of extra messaging to understand that they are welcome at the facility, right? And we have the capability to support them. So while this is not the only example over our time, currently one of these programs is our data science program. And this started several years ago as a way to help data and learning driven projects overcome technical barriers they might have to using high performance computing resources. And the idea was, sort of an explicit call with an explicit program, might be catch people's eye more readily than just, saying, oh, please come apply. Instead, this is, hey, please come apply, and we'll have staff and resources available for you to use. And so this has been a very successful program, actually, over the course of its few years. We have had projects really do exactly what we want them to do, right? Which is successfully be using HPC resources, compete for time through the Insight and ALCC programs, and be very, very competitive. So it's been a great program. It's continuing. The call is currently open, so I encourage you to go look and explore the potential opportunities for you there if you're interested, and think you might have a compelling project to sort of compete there. But the premise really is not to get sort of a big amount of compute time. It's really to get some compute time, to get some time with ALCF staff, and to collaborate on improving that readiness. So it has a big overlap with the same mission as sort of the regular pool of the discretionary program. But it's right now just sort of trying to make sure that this community understands that they're welcome, and that we want you to be using the resources. One of the other big programs we run out of the DD pool is our early science program. A lot of history has told us that scientific applications generally are one of the most effective ways to burn in a new large computer. Probably any computer, fairly. But if we want to find software bugs and hardware bugs, scientific applications can really do that very effectively. So for many deployments, we run an early science program. And so this is where we have a handful of projects that we collaborate very closely with. These are research projects. They have a large scale problem that they want to run on the new machine when it might come. And in exchange for that, right, in order to be able to get that head start on being ready to run on that machine, they help us debug the machine. They help us debug the software and improve its readiness and improve our understanding of how to use it. So this program is not currently open because Aurora has an early science program that is full. But as we look into the follow-up for Aurora, which is disturbingly, closer than you might think, just considering it's not on the floor. If this is something that's interesting to you, I encourage you to keep your ears open. This used to happen on a much more tight time frame of about 5 years, and then just a lot of changes with exascale sort of extended the windows there. But we expect that the windows might actually start looking sort of more tightly coupled than they have in the past few years. All right, and so those are the primary big pools that we use the discretionary space for, and actually a large fraction of that time really does go to those readiness programs, both the general sort of independent projects, getting a DD to get ready for Insight or ALCC, but also through the ADSP. There are other things that come up in that pool, but I think in terms of the context today, these are the most useful bins to think about. I want to switch now to talking about Insight and ALCC. And so these are the major ones. These are our flagship programs, especially Insight. And and I'll talk a little bit about the requirements. So particularly for Insight, I'll say that if you're considering Insight, starting in the new year, in the spring, the call for 2022 will be open, and we run at that time, right? Once the call is open, multiple webinars so that people can get in, talk to us, right? Talk to the people running the program so they can understand what they really need to think about in terms of writing their proposal. I suggest you think about it earlier rather than later. So there's earlier ones not long after the proposal, after the call is open. So I encourage you to look out for those. So Insight is a joint program for the two leadership computing facilities, both at Argonne and Oak Ridge. They're annual, so every year we have the call, and so that the awards will be available to use from January 1 to December 1. And again, repeating the theme, it's open to anybody to apply. If you're going to publish your work openly, you are free to apply. But sort of what comes with that is that there is a pretty thorough and hard two-part review process. The most important review process is the science review, and I'll talk about what that criteria kind of looks like. And the second part of that review process is your readiness review. Sort of make sure that if you get this award, you're ready to go with whatever your plan is, and that it's not, you've got your award, but oh wait, I have a year's worth of development to do before I can do anything, and then your first year's time doesn't get used. So I'll talk about what that kind of looks like in a tiny bit more detail, and know that you can go look for more when the call is open. These tend to be big awards, as I mentioned. So the total node hours on Insight on Theta available for Insight is 17.8 million node hours a year. So projects range from about 1 to 2.5 million for each calendar year. So it's relatively large and not that many projects. And last year we were almost 6 times oversubscribed in terms of request. Don't mean that to dissuade anybody from applying. I just mean, I encourage people to sort of think about the level of competitiveness there and the requirements on the proposal, and to take it pretty seriously. That you absolutely very likely to be competitive as long as you write a good proposal. So the primary criteria, as I said, is the science criteria, and this is really looking for research campaigns that have a chance to really significantly change their field or have a significant amount of impact on their community. And that is broadly defined, right? Generating a huge data set that your entire community can use is a huge impact. Changing the way you think about a particular, physical mechanism in a star is also, large impact. It's pretty broad, right? And in the end, right, it's also very domain specific what that impact can be. But that's what we're really looking for, right, is that really high impact, but also often high risk component to these projects. I've already talked about this, but in the end, we're also looking for this readiness and computational leadership criteria, which is really understanding that this project needs to run at something like a leadership computing facility just because of some component of what it's doing, or multiple components if necessary, right, that you really need the capabilities, the architecture, something, right, that you can't do elsewhere. And again, the only limitations we really run into is there's this very small number of countries that we cannot give accounts to. And so if a PI were to apply from, say, North Korea, it is very hard to actually move forward with that project. All right. And this gives you a little bit more detail about what the twofold review process means in terms of looking for that that scientific merit, right? And understanding that you have a team ready to go, that the request is reasonable, right? That given the problem you want to solve, that it's worth the amount of compute or data that you need to solve it. I will say that Insight can be 1 to 3 years. So when it comes for your renewal, if you are a 2 or 3 year project, you don't go through the entire new proposal assessment. It's really looking at, given your original proposal, you had a plan for year 1, and if you were, if you're going for your 3rd year, a plan for year 2, and it's looking back on those milestones and making sure that you're consistent with your plan, that you're still working on the same problem that you originally proposed, and making sure basically that you're on track. We actually do most of the time have proposals that are fine in their renewal, but absolutely sort of stuff happens, right, when you're doing research. And we have absolutely had projects that have had to shift direction pretty substantially. And they have either, in some cases, those projects have made the assessment that, you know what, this is now a new proposal. Like this is, I wouldn't get through, you know, sort of looking at my original milestones and my original proposed scientific problem and have that look like the same project. So they choose to go under a new proposal assessment. But at other times we have had projects apply and actually be rejected because it does appear too much like an entire new proposal, and the review committees can't sort of connect the dots and really make that consistent. And their response to us is, please make this a new proposal and come back again. Since I alluded to it, I'll say that the review process for the peer review component is done by domain in a broad sense, and it's a panel review. So we will collect, depending on how many proposals in a particular area, between 10 and 15 experts in that area, and they are looking through all the proposals, at least three reviews per proposal. There's a conversation about every proposal to sort of talk about it a bit. And in that review process and that like day where people sit down and discuss the proposals, they also provide us with sort of a ranked list, right? So if you look at that particular panel, if you're looking at, you know, the biology per panel, it's looking at all of the proposals and sort of giving us a ranked list. And there's, you know, sort of like a group at the top where there's a line they'll draw that says, you know, really, if you can, fund all of these. A group in the middle that says, these are good proposals, right? But, you know, they're not as urgent as this top bunch. And then another line at the bottom where they'll say, you know, don't fund these, there's some critical flaw. And generally we have found that very few proposals end up under that bottom line where they're not deemed meritorious at all, like not to fund at all. And that we're looking at this very, very top few in that top group for allocations. And as I talked a little bit about the computational readiness for the proposals, this is done by the LCFs. So the LCFs jointly run the program, and we also jointly run a computational readiness for all of the different proposals coming in. So somebody from each facility will read each proposal and look for the technical readiness, whether things are working or running already, whether they're actually proposing something that will work. Basically, the shortest version of this is, is what you're proposing going to work on our system or not? And if it is not already running 100%, right, how far away are you from being able to run 100%? And then the input from all of that goes to the awards committee, which is the LCF directors and directors of science and the Insight program managers. Program manager, sorry, one. But the top thing, right, the primary criteria is that scientific peer review panel. And the computational readiness is to help us understand the risk. So we're really looking at the top scientific projects and that technical readiness review is helping us decide, you know, are these top 3 projects incredibly risky and we'll have to put a lot of people resources into them, or are they a relatively safe bet? And they help us manage our people resources that way. So you're not going to, you're unlikely anyway to sort of be kicked out of the Insight process just because of a CR unless it is completely unready. But we rarely see projects that are the top tier in their science that are completely not computationally ready. A couple, and I'll go through quickly on this, a couple of recent trends in Insight that I think are useful for this community. We have seen a significant increase in projects that are using both more data-driven or learning-driven or learning techniques in their proposals. And this includes you know, using surrogate models within you know, a more traditional simulation, to projects that are really foundational, like looking at more of sort of technical aspects or the mathematical aspects of learning and trying to scale up learning approaches on big systems. So we have seen over the course of the past few years actually a pretty big increase in that. The increase has been big enough that we have what now is a distinct learning panel, which is unique with the way that we've done this, right? So we don't have a finite element panel, right? Or something akin to that, right? But what we did was create a separate panel of people who are expert in learning and data techniques, so that for projects that are introducing these aspects to their proposal, this panel can help us assess, right? Are they actually making good use of learning techniques? Are these reasonable approaches for the problem that they're using? Or are they just, throwing in learning because it's a buzzword? Or do they not really have a plan, or do they have a great plan, right? And therefore, to not worry about this approach. And in some regards, it's almost, we don't think of it this way, it's almost like a third prong in terms of readiness, right? Are there methods that they're using in learning or for data the right ones? In addition to that, right, this panel also will look at these foundational learning proposals and sort of look at those separately, right? If you're looking at fundamental learning research, right, in terms of scaling up methodologies or new applied math or something akin to that, they're looking at those sort of on their own merits and giving us an assessment and a ranked list with those. All right, and this to give you a sense of numbers for the past 2 years of Insight Awards, 2020 and 2019. And what I think I'll primarily say out of this is you get a sense how we've decreased the total number of projects on Theta through Insight in order to give projects a very competitive leadership level allocation. So 14 is a small number of projects. It's hard. It's hard to do that, right? And out of a lot of really good proposals, but it gives you a sense, when you're looking at a lot of projects applying, it's a competitive process. The ALCC proposals, this is a little bit shorter, and I'll explain why. So the Oscar Leadership Computing Challenge, it runs every year. The allocation year then is from mid-year, June through 12 months. The letters of intent for this coming year, so 2021 to 2022 are due now. As I mentioned, they're necessary if you think you might want to apply for ALCC. They're relatively modest. They're not super long, but I encourage you to take them seriously if you want to apply. They're due January 4th. They are probably going to down select based on these letters. So I don't necessarily mean that to scare you away, but sort of to help you understand that, they're due soon. They'll be down selected based on them, and sort of to give it some thought. So these tend to not have the same level of readiness requirements always as Insight. They don't do as thorough of readiness review. And by they here, I should say that this is run entirely by Oscar, our primary sponsors, and the Office of Science. And the total size of these awards is wildly variable. They are sometimes at the scale of a discretionary award all the way up to the size of a large Insight. And it's really Oscar's discretion whether, along with the people they bring in to help them run that program, whether they want like 2 really big programs of projects or a large number of really small ones. This year in the 20 to 21, we have actually a great number of ALCC projects. I don't think that will be repeated. Again, I think it'll go back to sort of the more what we expect, sort of in the 5 to 20 range. But the key component to this program is that they're looking for projects that align with DOE mission, but that DOE mission, can also align with broader, national need, right? Depending on what's going on. If, in a different model, or not a different model in a different year, right? Or a different alignment of allocation year, you could have expected that a lot of COVID-19 research might have ended up in the ALCC program. It did not, just because of the way allocation years worked out, but we've supported a lot of COVID-19 research out of sort of emergency unused time and discretionary. But like that would be it's not just DOE's mission there, it sort of aligns with a national emergency and so something to consider. Right, and as I promised, right, this is the slide coming back up from earlier in the talk. It's really, for the most part, everything I've talked about is sort of smashed into this. It can give you a sense of the scale of each program, and hopefully you get a sense of where you might align, right, in terms of where you are with your project right now. All right. There we go, sorry. Are there any questions?
Thank you, Katherine. Anybody have any questions?
I have a quick one. Just, are those slides available on the website?
They will be. The previous versions of these slides, which are very, very close, are available, and then I will send these off immediately to be up.
Okay, thank you.
Yep.